metal forming process or mechanical working of metals can be simply understood by a very familiar process of dirk making. In case of dirk making, we have raw material as flour mixed with water and sometimes yeast. We can make this dirk into any desired shape by applying load using hand or any other equipment. We can use this same dirk for making pizzas or rotis and chapatis. Something similar happens in case of metal forming as well. We apply load to raw material like bloom, billets, slabs, etc. using various specialized equipments and machinery. In order to get outputs as such strips, coils, bars, beams, channels, tubes, wires, and the list goes on and on. So we can say that the raw material in case of metal forming, that is the hot metal or sometimes cold metal, is equivalent to dirk, whereas the output of metal forming process can be considered as pizza, roti and chapati. Now to understand the metal forming process, let's take the example of the most prominent mechanical working process, rolling. In rolling process, the raw material, that is billet or bloom, is rolled between two rollers and a final shape is obtained. Here we are giving an example of I-section beam, which is a structural entity, as the outcome. Now to change the shape of raw material, the rollers are applying certain amount of force. This load is such that it generates a stress sigma which is greater than the yield strength of the material but lesser than the ultimate tensile strength. Now this sigma y is the yield strength, which is that strength of material up to which elastic deformation takes place in the material and beyond which plastic deformation occurs. And hence the applied load should generate a stress higher than the yield strength. Now this sigma ut is nothing but the ultimate tensile strength, which is the maximum stress that a material can withstand while being stretched or pulled prior to breaking, and hence the applied load must be generating a stress lower than the ultimate tensile strength. So for proper metal forming process, the raw material must have low value of yield strength, good ductility and good malleability. Now the metal forming process is trifurcated into hot working, warm working and cold working. The hot worked process is considered when the temperature of operation is higher than the recrystallization temperature of the material, and when the temperature of operation is equal to the recrystallization temperature, which is given by T suffix R, then we regard the metal forming process as warm working. And if the temperature is lower than the recrystallization temperature, then we regard that particular metal forming process as cold working. In order to understand about recrystallization temperature, we first need to understand what is this recrystallization process is and why and where it is needed. This we are going to discuss in the next lecture.